Alright, let me sync to preview player real quick. What does this do? Here we go. We're live. Go ahead and mute this just so I can see myself there. We got the public view. We want to view that on a separate tab, I guess, huh? We go here. Start a broadcast. Okay, we got that. It's good. Weird. Alrighty. We're good. We're live. That's good. Yeah. Okay. That is starting. Excellent. Okay, so now the only other thing we got to do, got to delete this. We got to go to our scheduled events and start. Read more in 10 minutes, huh? In 10 minutes. Hey guys, I'm writing a game engine in Python. Ask any questions you like on the stream. Boom. We're golden. We are golden. Awesome. Good stuff. Okay, I'm going to start some music going. Nice easy stuff. Oh shit. Stupid. Stupid me. That's okay. Probably should start it over anyway. That's looking good. Looking good. Alright, got everything set up. I think we're ready to go, surprisingly enough. That's terrifying. Okay. Looks like we're doing good on that front. Good stuff. Good stuff. Alright, we're ready to go, I think. Cool. Oh boy. Thump, 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 thump. I am so not ready for this. Who the hell downloaded me, ass? I think we're ready to go. Alright, so first thing I gotta do is some documentation work that I was really lacking from earlier today. I mean, really lacking. So I'm gonna start Awesome, we are ready to go. This is exciting. Okay. Alright, plug in the phone. We are settling for this long coding, hopefully. Because that's fun, right? I love programming, actually. I really do. Cool. So we've got 2 viewers right now. Cool. Alrighty, so just doing some, let's see here. Right, I decided render actually is not necessary, so we're going to delete this. Rightio. The default, update, non-fixed. Provides capability. Let's see here. Should be called only from game class. As updates should not be missed. Alright. Default fixed update system should only be called from game class, as fixed updates are even more sensitive to time delta So let's see here. Adds an entity with the name and returns its ID. Good stuff. All right, so we're getting started here. Let's see here. Remove entity. La-ti-da. I am so not used to this whole streaming thing. It's something I'm still definitely getting used to as time goes on, which is fine. I mean, I enjoy it for sure. And the stream is live. Please. Alright. Here we go. Let everybody know the stream is live since I'm dumb and don't know how to use this subreddit, but that's okay. Close. Error. Entity does not exist in this world. Go as a system. That's a system to work. Also calls system.setup to do any initialization required. Oh, whoopsie. Tear down work, the application, etc. Good. So what I'm doing right now is going through and commenting some of the code that I wrote earlier today, because while it's not particularly messy, I don't want to leave that be, because if you leave it for too long, you never do it. So I just want to do the thing. All right. So let's see here. Ooh, this should acquire a lock, shouldn't it? I was thinking I should probably not try block this. I should probably let the end user handle this, because that's kind of an end user problem. You don't want that. You want it to fail loudly, right? Oh, hey Sean, how's it going? Dude, it's great to see somebody else on the stream. I mean, this is the coolest thing ever, just talking through all this kind of stuff, and I just love it. So I'm really excited that you're here, and I really hope you enjoy it. Let's see here. So attempts to name if the component does not resist. Returns all components of a given type. Hey Thomas, what's up? Yeah, I'm just writing a very simple game engine in Python. So basically the idea is I'm trying to take all of the crap that makes game engines really terrible, and I'm trying to abstract that away from the end programmer as much as possible. So I'm building this really simple entity system right now, and then kind of the end goal is to abstract away all the threading, all of the locking nastiness. The end programmer doesn't have to touch any of that. So that's kind of the goal. Oh, dude, Sean, very cool. So yeah, you know, Python is an awesome language for GUIs because you can iterate really fast. You know, I'm working on something in Qt right now, which is C++. Although there are actually Python bindings for it, and doing it in C++ is just horrible because you have to deal with a lot of templating and a lot of extra crap that C++ makes you do. And so the great thing about Python is you've got this really quick loop of, oh, this didn't quite work, let me change my script real quick and run it again. So Python is an awesome language for that kind of thing. Yeah, so my #1 resource for learning Python would definitely be the Python guide that exists in the documentation. It's like a 15 or 16 step guide. It's super, super easy. So that's definitely where I would start. PyQt, there are lots of tutorials out there for that. I don't know, you're probably using tkinter as your GUI library, and while it's okay, and it's standard, Qt is way easier. So I would definitely try that. Runs fix updates components, and that's that. Cool. Yeah, I mean, you know, TK is one of those things. It reminds me actually a lot of Java's Swing library. It's very, very powerful, but it's so incredibly unfortunate is the word I would use. There have been a lot of unfortunate design decisions over the years. So it becomes kind of a pain in the ass to use over time, but you know, you get used to it, so. Yeah, I mean, Python is a great place to start if you're learning to program. If you're doing it in school, I learned I learned Java first, and I think that learning it in school, that's probably the quote-unquote right way to go, just because, you know, in school, it's all about learning proper coding practices from the very beginning. But, you know, if you're just a hobbyist, or if you're just trying to pick it up for fun, Python is great because it doesn't bog you down with a lot of garbage like a lot of other languages do. So I think the only thing is just make sure you read lots of code and you get used to writing good code from the beginning, and that shouldn't be a problem. Oh, the init description, whoops. Okay. Default update function doesn't do anything. You should probably override this if you're fixed update function doesn't do anything. You should probably override this. I can't spell today. This is terrible. Okay, give me a second. Oh, God. Oh my God, I cannot spell. This is terrible. I am so sorry. Oh, jeez. There we go. Cool. So there's that. set up a function. If you need to do any extra work or your system can't be used, put it here. Default tear down function if you need to do your system. For your system can be I should probably put that mention there. Okay, a couple of notes here. Let's see here. This class is just a little tricky. Name system. Oh, actually, you know, Sean, it's not all that complicated. So basically, all I'm trying to do is I'm trying to create like a hierarchical system for game objects. So how this works is you have a world that contains entities and systems. The entities can have sub-entities and components. And basically, entities are just containers for data, and components have different things that they do upon game updates. So then systems happen after the update, and they can basically take a whole class of entities. So for example, every entity that has a physics collider might go into the physics engine, or every entity that has a sprite might go into the graphics engine, or the graphics system. So basically, that way you can do your updates and then do whatever extra work you need to do. That's kind of the idea. It makes it a little bit easier, I hope, on the end programmer to make it a little bit simpler. So, yeah. It's really not that complicated, I promise. I mean, yeah, it's like 300 lines of code, and there's some other stuff that I've got written, and part of it probably is since I'm using Vim. I mean, Vim is a really scary editor if you haven't really gotten into it, so, you know, it's one of those things that you get used to it over time, and I highly recommend learning Vim while you're going, because it's just so incredibly powerful. But, you know, again, this is a personal preference thing, so that's just my opinion. Except it types a list of that could be part of a system, i.e. a physics system might have kinematic colliders, or kinematic bodies, and static bodies. Let's see here. Component name, the name of the component. You know, PyCharm is actually really nice. PyCharm, I've used it a little bit for Django, which is a web framework, and it's really nice because it does a lot of the deployment for you, which saves you a lot of time, like doing all of the, you know, putting stuff together. Yeah, I mean, in terms of learning Vim, there's a program that comes with Vim called Vim Tutor that teaches you the basics, and then there's a really nice distribution of Vim, like Vim plugins, called, I'll type it into the chat, but it's SPF 13 Vim. And basically what this is it comes with a bunch of plugins pre-configured and a lot of features that make life a lot easier for for anybody who's doing any sort of programming. Python especially is really well set up. So I highly recommend you check that out. Just a little bit of a plug for a project that I really like. So yeah. Let's insert it into is this a fixed update process or not? If you have no reason to make it fixed, then don't. There's, oh, I should tab that over. Whoopsie. Back. Go. Okay. Okay, so I like how this this is looking so far. I just gotta finish. I've got to finish documenting all of this. That's kind of what I'm doing right now. It's a little bit boring, but it's one of the, you know, documentation throughout the entirety of the project is really, really important. Otherwise, you get to the situation where you have thousands of lines of code that you have no idea what they do, and so I don't want that to happen. So I'm trying very hard to be a good Python programmer from the very beginning. Attempt to register an entity system. If the type of component you're trying to add is not one of those in accepted types, this will not add to note, this modified entity has to add in the appropriate type of Actually, no, there's an exception built in, just kidding. That's convenient. Good. So... there we go, there's that. Post-process. So... entry point. You should definitely practice to do. I know Python needs Alright, so that's all that documented. Goody good. Cool. I like that documentation so far. It looks pretty good. Check something real quick. 3 concurrent viewers. Holy shit, that's awesome. Alright. Let me refresh this real quick. Alrighty. Good stuff. Alright, so... anyway. Touch... Cool. Okay, so now what I'm going to try to do is I'm going to try to I know it's wrong. It's fine. Get over that shit. There we go. Try filling this again. See what happens. Good. That should have opened the... Didn't. That's weird. Alright, so let me figure out what's going on there. That is very odd. Hey, Thomas. So, my background is actually in computer engineering. I'm a student at the University of Illinois. I'm in my 3rd year, so yeah. Basically, my background originally was in a lot of kind of embedded development and hardware stuff, but I'm kind of working towards getting more used to not that is kind of like, what the heck? Why is it so big, right? That's weird. That's really weird. Why would that be happening? Oh, that's different. Okay, I got you. I got what's happening. That's my bad. Damn it. I hate it when I make breaking changes and forget to propagate, you know? This is when you're actually using it. Holy shit, I gotta reload this one. That's okay. Not that big of a deal. But, right. Oh, jeez. Oh, it's important. So that's fine. Okay. Now this should work. SH. Yeah, so again, if you guys have any questions about what's going on or what I'm doing, please just let me know. I'm happy to answer questions. So, yeah. It's a window, it works. Awesome, good, okay, and it closes properly. That's very important. Okay, cool. So now that that's working, actually, Thomas, this is Sean, this is actually my first stream I've ever done with this code. I've done a little bit of streaming of some other stuff, but this is, and that was on Twitch, but this is my first experience here. So that's really exciting. Yeah, so, you know, I'm trying to get more into this. I'm really into this project, and so I've decided that the way to keep me on it is to force myself to stream, because I figure if I have people who like seeing me do this, then I will be more likely to actually keep with it. So that's kind of the goal right now. But, yeah, so let's see, from, it would be engine.core, yeah, no, actually, it would just be from, stupid, control P, engine system. Yeah, I'm just gonna import entity system. That should not break anything. Good. So now what we're gonna do is we're gonna say self.world is equal to entity system dot, and then this is going to need, oh shit, I don't remember. Yeah, what I want is, you. Good. Okay, that's what I wanted. Oh, geez, it's 4 a.m. over there? That's terrible. Oh, I'm sorry. You know, this is just the only time that I have because school is so crazy. But, you know, all of these are being recorded, so, you know, if you have any questions, please just leave them in the comments or whatever, just to make sure that I can get to them. But, yeah, for sure, I definitely want to help you out if I can. So, yeah, yeah. I'm sorry. You know, this is just kind of the time I have. I mean, getting towards the summer, it'll be a little bit easier to stream at a little bit more of a reasonable time. But this is what I got for right now, so yeah. Sorry. Okay, so let me figure out what's going on here. Here we go. There we go. And toggle the help. There we go. So now we can drop over here. Okay, cool. There we go. Okay. I didn't think it needed anything to it. That's good. There's that. That's fine. So that's the event callback. And we're actually going to have to make an event system a little bit. So, world.update data. I can't type. This is bad. There's all of that. That's good stuff. Okay. I don't think I need this here. That's true. This should run just as is, but, you know, I'm paranoid, so. Shell. This is one of my favorite features of Vim. I can run a shell inside of here, which is kind of cool. So, Python, game.py. Okay, nothing broke. That's good. That's very good. Nothing broke. That's the important thing. Alright, so there's that. Well, that's cool. It's really smart. Okay. Sorry. I'm reveling in the intelligence of whoever wrote this. Okay. So there's that thing. I like how that's going. So let me check my viewership real quick. Concurrent viewers. Okay, cool. So we've got a 720p streamer and that's cool. Okay. Gotcha. Good to see all of that. Good to see all of that. Awesome. Cool. I'm just checking stats right now. I'm a stats junkie, so I like to see how I'm doing, if that makes any sense. Anyway. So, yeah. Let me go ahead and delete this actually. So this is a very basic game. This is like the simplest game you could possibly make. Alright, yeah, so, yeah, basically the end goal is to have an engine that is very portable to other games, but right now what I'm working on is a 2D platformer game. I don't want to get too much into the specifics because I haven't really gotten past the very basic prototyping stage, so it's not really going to be an MMO. I really just kind of want to stick to a single player, 2D side-scroller kind of thing right now, just to keep it simple. But I'm trying to make as extensible a game engine as possible, so I guess it's theoretically possible that you could make a 3D game or a 2D MMO or whatever you want with this, but right now my goals are very small and self-contained to make life a little bit easier. So there's that. Let's see here, alright. So what I need to work on next, I guess, is my event handler. because my event handler is kind of a joke at the moment. So, but I really want to work on graphics. I should really do events, shouldn't I? I should really do graphics first. I should. Okay. Let me untoggle this because I don't need that anymore. Let's see here. This is going to be GFX render system. Excellent. Okay, so let me think. Where do I want to start? Where do I want to start? That is a tough question. I'm going to look up some source code real quick. Let me show you what I'm looking at, actually, because that's probably not a bad thing to show. Yeah. So, PySDL2 docs, good. API reference. I don't need any of this, I don't think, so that's good. But yeah, so basically I just have this up because I just want to show you guys what I'm actually working on in terms of, you know, how I look at documentation and kind of how I put together all those ideas. So that's kind of what I'm going for here. Let me see. Yeah, let's go to library wrapper. I might use the X because this is just a little bit easier. 2D drawing routines for software. I don't want software. I want. They do have the event handling, which I'll probably use because it's easy. Here we go. This is probably what I'm going to use just because it's a little bit simpler. Okay. So let me do this with that. Let me open up my terminal. Here, let's do this. Oh god. Right. Alright, here we go. So now. Go. Okay, cool. I also want to do... No, actually I don't need to do that because I'll just have it throw sprites into all of them. That's fine. Okay, so def. We're going to have... I just want to make sure it worked, honestly. So we're going to have class rendering system entity system dot I don't remember. Sorry, my Python knowledge sometimes fails me, so I have to go into the docs for a second to figure out what's going on, but that's okay. So it's going to be Python parent structure. I always forget how to do this. It's a little bit weird. So, right, the first thing we gotta do is call the parent class, I guess, right? So we're gonna say, right, super system self.init. This is going to have lots of things in it, isn't it? So it's going to have name, which is system, accept a type, which is going to be import 2.next, import. I don't know exactly what we're going to need here, so we're going to figure that out real quick. Here we go. We're going to use this guy. Actually, let's just import SDL2.next. So then this is going to have two dots. Right. Now what I'm doing here essentially is one of the cool things you can do is you can pass types and functions as if they were variables, which allows for some really complicated programming, which I really like. But anyway. Let's see if this works. It should, but I'm not sure. Component name is going to be sprite. Then false. Oh. C system, really? So that fixes that problem. Okay, cool. So we're gonna have all that going, which is nice. I don't think this needs to do anything else other than no, it does. Just kidding. Self.sprites equals just an array, just to keep easier track. Well, no. We are going to have components, we don't want to mess with that, so that's fine. I think that's all we've got to do, really. So then what we're going to do now is we're going to say, check how I did this down here. We got to do is post process, right? Post process data. I think you can just yeah, you can just do it. You don't have to do any special notation or anything, right? Delta. Let's see here. Delta is surface. That's the one thing. I knew I was forgetting something. I knew I was. I'm glad I found it, honestly. So then, we actually do need to change this up a little bit. Since we want to use Sprite Factory here, Sprite Factory forces us to override the default register entity function. And the only reason for that is that basically we only want to get sprites from the Sprite Factory. It's definitely the easiest way to go, that's the thing. So I don't really want to mess with it. So yeah. Alright, let me see something here. We're doing pretty good. 4 concurrent viewers. That's good. Good, very good, very good. I like this. This is awesome. So, yeah. Yeah, I'm really having a lot of fun just doing this and, you know, having you guys talk to me. It's really great. So, keep it up. It's great. So, yeah, I know that now. I'm being stupid, that's fine. Okay. So we're gonna have to redo register entity here, so that's fine. Not that big of a deal, but we gotta redo it, which is kind of a pain, so. Because this doesn't actually need, I guess it doesn't actually need a type because there's only one possible type we could use, right? But then the question is if we want to do something like an animated sprite. That's the thing I'm worried about. We're trying to do like an animated sprite, so that kind of worries me, which is is equal to SDO2.x. Sprite Factory. All that's proper. That's good stuff. Oh, I didn't know that. Sorry, let me turn it down a little bit. Sorry about that. Oh, Jesus, it is. Okay. I hope that's better. I'm sorry. Yeah. Is it any better? I'm really sorry about that. I might just steal this sprite render system. Yeah, I am definitely going to use this because this saves me a lot of time. Oh boy, does this save me time. I'm going to use this. This is going to be great. This is going to be great. Okay. Target, okay. Yep. Self render system is going to equal to 2.texture sprite render system because I'm lazy. Oh well, that's okay. Okay, this should be actually back. Windows. Yeah. Okay, cool. Well, that's weird. Let me refresh this. Something weird just happened. This music's getting weird. I'm going to change it. Okay, that was getting weird. I'm going to change it to a different one that I kind of like a little better. There we go. Musicforprogramming.net is awesome. So, highly recommend it. Huh. Very weird. Why is that happening? Great, well that just crashed. Let me see something real quick. Sorry, the chat in CodersTV just crashed, so I have to reload it. Give me just a second here. It looks like CodersTV is getting all messed up. Oh no, it's back, maybe? Maybe? I think it's back. Okay. Yeah, I think it's back now. That's good. Cool. I love analytics. Analytics are fun. Cool. Very cool. For briefly, that's kind of cool. Okay. Let me refresh this real quick, see where we're at here. Awesome. Awesome. I love me some visibility. Visibility's great. That makes me happy. Woo! Alright, cool. So yeah, there's that. So we're going to steal this render system from SDL2.ext because I'm too lazy to write my own. And I have no shame in saying that whatsoever. Anyway. So we're going to have our texture sprite render system. That's gonna be, ooh, that's gonna be bad. Let's do self dot window. So equal to sprite factory dot sprite factory. We want to do let me try doing it this way. This is probably the more proper way to do it. So we're going to say self dot. No, I can't. What the hell? My F keys. Okay, this is not good. This is not good. Okay. Self-test sprite factory. Create texture sprite. Yeah. Okay, let's do this the right way. There we go, that's better. Okay, I don't see any of you guys chatting. So if there is some chat going on, I don't see it, which is kind of frustrating. Let's see. There we go. That should help fix that problem. Alright, cool. Self.spriteFactory.create texture sprite, and then it's going to be okay, cool. Okay, cool. All right. Default args. Yeah, it should be good in terms of. This is probably the wrong way to do this. Let me try doing this a little bit differently. Dot create. I can't type today. That's render system. And then this is going to be using that should work, I think. Yeah, so I've been coding in Python on and off since probably 3 years ago, I want to say. I really got into it about 6 months ago. But I've been doing Java, C, C++, and System Verilog for probably 5 or 6 years total. So I have some experience, but no, I started Python a few years ago, and I really got good at it. I really started getting good at it about 6 months ago, I would say. Or at least I hope I'm getting good at it. I don't know. That should work. And then create texture sprite. We just need... Yeah. A size needs to be provided. The rest of it can be taken care of, right? Yeah. Okay. So we can probably just pass size into here. Or we can do this. This probably should make more sense. From image. Cool. So that should all work. Good stuff. All right. That should work. Then that's all. It should all be. Okay. Entity. Go. That should probably work fine. I think. Just trying to decide. That should work. Okay. Let me do this. Def add sprite entity wrapper. Let's see here. This is a system-specific wrapper to the built-in function. Using wrappers like this is highly encouraged to increase readability of code. This basically just lets this software, or the tester rendering system do its stuff. Cool. Okay, so now what we're going to do is we're going to do a based on the set sprite type, which is good. I want to make sure I specify that just to be sure, because I'm paranoid. We're gonna say stl2.texture. Put that in there. Oh, undo, please. And that makes this way more sensible. Way more sensible. Way more sensible. Okay, cool. So now we got that. Good, good, good. We're gonna grab sprites from there. That's good stuff. All right. So we should just let that do its thing, I think, right? This should not be complicated, because uncomplicated is way better than complicated in every case. Even if it's a little bit less intelligent, it's always much nicer to make things as simple as possible. So that's kind of what I'm going for here. It says 5 concurrent viewers. That's exciting. Holy shit! 5 concurrent viewers. That's awesome. Do this on YouTube as well. Let's just pause this. Give me just a second. I'm going to try to be keeping up the YouTube comments and the, Good. That was easy. That was easy. cool. Delta's in use. Basically just lets the texture rendering system do its stuff. Essentially all we're going to do is we're going to say self render system. Okay. Awesome. Awesome stuff. Let me do this real quick. Definitely don't need either of these running, really. Up there. Some comments from energy in the chat position. I didn't. Okay, that was bad. Okay, cool. Self.render system dot render. Let me check the example real quick. I want to check something here really quickly. So I can do that. Okay, that's good. I might do that then. Okay, what I'm going to do here is I'm actually going to run another class. Render. Window. Window. And then we're going to do with my L key, it keeps bouncing a lot. It's fine. Self-dot. Silly. Alright, 3 watching right now. How exciting. Alright, so then here what we're going to do is we're going to say, yeah, that's fine. Yeah, sure. So basically, def init, what that does is whenever you create a new instance of an object, that is the function that's always run. So for example, let's say I have an object foo, okay? And the declaration for foo looks something like this. Oh, whoopsie. That was not well formatted. Let me actually type it up for you real quick. It's not a big deal. So let's say we have some class foo. Syntax set file type equal Python. Okay, so we have some class foo, right? We're gonna have some def init bar vaz, whatever. We're gonna say self dot bar is equal to bar, self dot vaz is equal to vaz. That's fine. How is this working? Okay. So now, let's say that down here, we're gonna have, you know, some other place in the code where you're gonna be using the foo class. So you're gonna say maybe object is equal to foo12. Now, if we print object, what are we gonna get? Well, we're gonna get, well, sorry, no, we don't print object. Sorry. But basically, object is going to now contain these values for bar and vaz. So basically, the init is just kind of the way that Python designates what the constructor is. If you know any object-oriented programming, it's the same thing as a constructor. So basically, you that is the first function that is called whenever a class is created. We can actually try it out in Vim Shell real quick, so I can just show you how this works. So let's just open up the Python interpreter. Here we go. So we're going to create a class foo, just like I said. Then we're going to say def init bar vaz. Cool. And we're going to have a self.bar is equal to bar, self.vaz is equal to vaz. So now, if we say, for example, object is equal to foo12. Oh. Whoopsie, I screwed this up. I'm sorry. I suck. I'm sorry. Let me help. Let's see if I can make this make a little more sense. Open up Python. Class foo. Self bar vaz. I forgot the self part. That's kind of important as it turns out. I don't think it actually matters where you put it so much. I think it's just tradition to put it at the top. And the only reason for that is that it makes code much, much easier to read, you know? There are certain rules that have kind of been established over the years of where the constructor should go versus where the where some other stuff should go. So basically, the way that I've always learned is you always put your init at the top of the class, and you always initialize all of your variables inside the init, or at least all of the variables you know you're going to need right at that moment. So then we're going to say there we go. That might work a little bit better. So now we're going to say object is equal to foo12. There we go. Now we have this. So now we can say print object.bar, and we're going to get 1 to come out. So yeah, basically this is how you create classes that have arguments when you're instantiating them. It's called underscore init because that's tradition. That's what we've decided as Pythonistas is actually the word. That's what's been decided, so that's just kind of what we do. So yeah. I don't really have a better explanation than that, but that is what it is. So that, yeah. Anyway, just go ahead and exit out of here. Go. Cool. Let me just quit it's different. I hate it when this happens. Okay, we got some problems going on. Vim screws up sometimes. It's okay, it happens, but the way to fix it is you just exit everything. Fair enough. Gotta finish closing up all my buffers. Now I can Vim. What we're working on. Vim. Oh, there we are. There we go. Okay. That should hopefully have fixed any brokenness that might be there. Yeah, actually, you know, OOP is really, really simple. Object-oriented programming is one of those things that people make very, very scary, but it doesn't really need to be. I can explain to you some of the basics right now if you'd like. I mean, I don't really mind. This is basically just kind of some mindless drudgery that I gotta go through, so, you know, if you need to just get a quick refresher, that would be I'm totally fine with that. So, let's see here. I think I need to do a sort func, but I don't remember exactly how that works. Here we go. Sort func. Let's see here. Oh, yeah, no problem. All right, so let me just quit out of this real quick. That's fine. Okay. So that's weird. That key's bouncing. I don't like that. Oh well. Okay. Sorry, my L key is bouncing. It's getting kind of weird. So let me just open up a Python interpreter here. All right. So there are three big concepts in OOP, and they are inheritance, polymorphism, and encapsulation. So the easiest one to understand is encapsulation. Basically what that means is all of your data should be in the same container as the methods you use to act upon it. So for example, OOP is the reason that we can have a class that operates on the data that's inside it. So to give you an example, actually to give you a really good example, let me do something like this. cd /workspaces/ what do I have in here? I'm just going to show you some other code actually so you can kind of get a handle on how this is different. Oh, I don't have that. Damn it. Okay. I have so much stuff in here. I don't even know what half of this is, so just give me a second here. Oh, four-way project, that'll work. Okay. This is a project that I wrote a few months ago for a class. So let's do cd easy PNG. No, this is a bad example. Sorry. Looking for a better example. cd CUDA. I don't think, let me see here. Oh, right, it's called kernels.cu. Okay. So this is some C code, and C code is very, very scary, right? So some things that I want you to notice about this code is, for example, whenever we want to call a function, we have to pass in all of the data that we want this function to use. So for example, in this gradient calc kernel function, right, we have to pass in a pointer to some floats and a width and a height. That's kind of frustrating as a programmer because you have to constantly juggle with all these arguments and make things very, very complicated. So C is what's called an imperative language or a top-down language, and that means that the data and the code sit separately from each other. Let's contrast that with something like Python. See, I'll just put myself here. Okay, so in Python, we can create a very simple class, like class Fibo, or no, let's just do a class foo, that's fine. We're gonna say def init self as Go to self.bar equals bar, self.baz equals baz. Cool. Shit. Damn it, I hate it when I do this. Let me do that again. Okay. Now, oh, damn it, I did it again. Okay, what I'm trying to do is do a couple of different functions in the class, and I keep screwing it up. So give me a second to actually focus on this and get it right. Alright, so, class foo. Here we go. Def add 1. So this is a really trivial example, obviously. All we have are 2 functions. But what makes Python cool is if we have this foo 1 and 2, right? So now we have an object of the type foo with 1 and 2 in them, right? So what encapsulation allows us to do is we can call object.add1, and then we can print foo.bar, and we're going to see, sorry, my bad, obj.bar, and we're going to see it's incremented. So what that shows us is that in Python, each and every instance of an object has its own set of data and its own set of functions. So everything is encapsulated into one piece. So that makes life really easy. Encapsulation is something that you really don't play with all that much, but it makes life easy. If you just learn to program Python, you're doing encapsulation already. The next big concept that's a little bit harder to understand, but not terribly, it's called inheritance. And so inheritance works something like this. Let me open up a Wikipedia page on it. Here we go. Inheritance in programming. So what inheritance allows us to do is, in Python we only have single inheritance. So this means that we can have what's called a base class, which has some basic functionality implemented, and then a child class, which can extend the functionality. So for example, in this very simple example here, we can define another class called foo2, and it's going to extend foo, right? And then we can say the init is going to stay exactly the same. So we're just going to do this. And then it's going to be super self foo2 dot init bar baz. And then we're going to define add1 self as self.bar minus equals 1, just to get an example that makes a little bit of sense, I guess. Minus equals to 1. Now we're also going to define mult2 self, which is going to say self.bar times equal to and self.baz times equal to. So what inheritance allows us to do is, since we know that foo2 extends from foo, we know that everything that foo does, foo2 has to be able to do. That is kind of the contract that we have as programmers when we're doing inheritance. So, for example, now we're going to have an object called obj2, which is going to be a foo2 with 1 and 2 as its arguments. Oh no, I messed this up, didn't I? I did. Crap. Okay. So the goal here, what I'm trying to explain, is that basically I did this super thing wrong. But basically how inheritance works is it allows you to have what's called a hierarchy of classes. So one common example is, let's say you're making a very simple game, and let's say that you have players and a player and enemies. So maybe both player and enemy derive from some object class that's like everything in the game world. And so then the player has the attributes that are specific to a player, like, you know, it has to be able to take input control, it has to be able to have a sprite that's specifically for the player, it has to jump and run and shoot, etc. Whereas the base class might say, okay, we just have a position and physics and that's it. Then you go over to the enemy, and the enemy has an AI and its own sprite and its own shoot and jump rules. So each of these has a physics piece and a location that they both grabbed from the base class, but then each one also has its own attributes that it grabs. So basically the idea is, how can we create a system whereby you can refine infinitely deep whatever kind of class you need. So there's probably some really good examples in here. Yeah, here's a very simple Python example. So yeah, basically we're going to have a square sum computer thing that's going to take in an A and B, and it's going to send in x times x. It's going to say, it's pretty simple, right? So basically what we're doing here is we are creating another class that is derived from square sum computer, and it just has a different transform function. So if you call transform on a cube sum computer, it's going to use this transform rather than this one, because this one is sort of the one that's closest to where you're using it. So since cube sum computer inherits from square sum computer, the transform function is going to be from CubeSum because it was defined most recently in CubeSum. So yeah, I mean, that's kind of the basic gist of that. Now, polymorphism is something that's really, really scary, and it's something that you probably won't use for a while as a Python programmer. But basically what it means, let me pull up the Wikipedia page here. Computer science, yes. So polymorphism, it allows you to have a single interface to various different types. And that sounds like a bunch of CS mumbo-jumbo, and it is. So what that actually means is that you have, let's say, the easiest way to describe it is how Java does it. Java has what's called a template. And so a template might be, you know, in the case of our player versus enemy, maybe instead of having a base class, you have a creature template, okay? And so the template says, these are the functions that you must have in your program, or in your class, in order to be part of this group of classes. So what that means is, let's say the template requires that all classes implementing the template have a walk function, and a jump function, and a shoot function. The template doesn't care how those things are implemented, but they must all be there in all classes that are losing the word here, that are damn it, what's the word? Right, so the ones that are implementing the class, the template. So if you ever look up Java interfaces, that's a really good introduction to this. It's kind of hard to explain, but basically the goal is to create one simple interface that every other piece of the program knows that all things that inherit this template have this contract written up. So one thing that allows you to do is sort of multiple inheritance. So for example, in Java, or yeah, I'm using Java because it's just an easy example. In Java, if you need something to run inside its own thread, and you all sortable characteristic, that's actually a great way. These things are characteristics that your code implements. So this is how I'm going to describe this. Polymorphism is like, if you look at any human being, every human being has an eye, it has a head, a nose, and a mouth. Every human being has 2 arms and 2 legs. So every person on Earth subscribes to that. So they are all a polymorphic derivation of a template. So this has kind of been a little bit roundabout without adding all the extra where you don't have class. Please ask me any question you have. Yeah. We're going to call it a night soon here, Sean. I'm tired and I got a lot of work. So I'm going to try to stream again tomorrow. I am not sure if that's going to happen, but I'm definitely going to give it the best shot I can. So, yeah, I will definitely post on... Oh, awesome. Great. I'll definitely post on Watch People Code tomorrow as soon as I can with my plan. I will definitely be streaming on Sunday, but maybe not tomorrow. So I guess that's it. I'm going to go ahead and start shutting everything down. I really appreciate you watching my stream. And I also really appreciate, just talking to you. It's been great, and, I hope that your adventures with Python continue, because it's a really fun thing. So, I guess that's that. I will stop the stream now, and I will just say goodnight. See ya.